Hello, we are Team Liverpool, and our project is on machine learning for digital breast cancer pathology in Botswana. I'm Chris, and my teammates are Shivam, Ishan, and Herschel.
Just a quick overview of our problem statement. So in low resource areas, pathologists have little time and resources to efficiently analyze lab results. And our solution is to use machine learning alongside computer vision and app development and CAD modeling to help lower the cost barrier and help expedite the breast cancer cell diagnosis process, which we hope to achieve at least an 85% accuracy.
So the following is our decomposition diagram showing how each of our deliverables represent a subsystem. We start with the microscopy images that are obtained from our patient population sets. The central part is the application and machine learning model we are enhancing, which primarily includes the augmentation of images. The time spent coding can also be included as another input, as this project is primarily supported on the efficiency of our developed algorithm, which we continue to enhance. What we output is the diagnosis of the microscopy slides given to the pathologist and informed to the patient through our application.
Our prototype has 3 deliverables. The universal phone adapter is the first aspect of our project, where the user can take pictures from their phone of the histology slides via the microscope adapter. The adapter is a feature of our project that is primarily for consistency and comfort. The adapter makes it so the pictures taken by the same user are very similar, as this makes it easier for our neural network to process and diagnose them. After the user has taken an image, it is passed to our model, which was outputted by a trained neural network to categorize each image as either malignant or benign and healthy. The last aspect of our project is the app/website, where the user can upload the image taken on their phone for the model to categorize. This is for ease of use and future application, as it makes it easier to update the model later down the line when more data is collected.
So our microscope to phone attachment is our first deliverable. Currently, we have 2 designs, which you can see here, that we have begun to print and adjust. Once we have decided on a final design, our goal is to make sure various phone sizes can fit securely within the grips. After we have done that, we will align the phone camera to make sure that it can take clear pictures of the microscopy images. And once clear pictures are taken, we will upload these images into our model to ensure that the correct diagnosis can still be made from these images.
For our second project deliverable, we have the neural network and machine learning model. As of right now, we are using data from several databases, namely the BRCA-HAD, BRCA-HIS, and the Mendeley datasets. And we are planning to incorporate the BAC dataset later. As right now, we've reached about 95% training and validation accuracy, but our testing accuracy is only about 70% with a slightly better true positive rate. And you can see this raw data in the top right image. In the future, we're planning to get this testing accuracy up to 85%. And then also reorganize the data for training, because the data is a little messy right now. And we are also going to plan on pushing for further emphasis on the true positive rate, which means that a patient is correctly diagnosed with a disease when they actually have it, as opposed to a true negative rate where a patient is healthy and is diagnosed as healthy. Additionally, we want to test other models. And so far, the VGG16 model is the best one we've had so far, but we still have to look into the Inception model and perhaps other ResNet models. Lastly, we also want to use pre-processing methods to make the training better and make the images more consistent for training. And we plan to incorporate this testing by looking at the accuracy of each model and discussing the true negative and true positive rates.
As you continue to refine and train the neural network to obtain the highest level of accuracy, we have started the app development framework portion of our project as well. For its deliverables, at a minimum, we want upload capabilities and a relatively fast diagnosis with the model. And later, if we have time, we can look into adding additional features such as a login info. The login info would be included on the website as a cloud for data storage and ease of access for the pathologist.
The focus of our model, or the big picture for our model, is to streamline the diagnosing process for pathologists. We're not trying to create a new diagnosing process or replace pathologists. Our project is designed to help the pathologists in their work. The key component of that is the high true negative rate that Kristan discussed, which allows benign and healthy patients to go home confidently. Our project can then help pathologists prioritize patients with higher probability of having cancer. It will enable the pathologist to take a look at higher risk patients first. And when it comes to cancer, time is very important. So reducing the time before crucial care is given can have a big impact on patient outcomes. Thank you so much. Any questions?